So we're going to continue on with our accumulation problems. Up here at the top, I'm just going to give a couple pieces of vocabulary. The first one is displacement, because we're going to review particle motion. Do you remember particle motion, velocity, acceleration, speeding up, slowing down, all that good stuff? Okay. But from an integration standpoint, it's like we're reviewing all the things we did before, but from like the other side of the aisle. So the first one is displacement. That is your integral from A to B velocity dt. It's not any different than what we did last time. For example, with the monkey and the gopher, see how we found how much they accumulated? We went from 0 to 3 and we stuck the rate of change in there. We're just now calling that rate of change velocity. It's not any different though. Do you understand what I'm saying? Not a different problem. Oops, where are my passes? All right, so that's displacement. The next one is total distance. For example, if I got up out of this chair and ran down the hallway and came back and sat in this chair again, what is my displacement? 0. I ended up at the same place I started, but my total distance was actually quite a bit, okay? So it's the exact same thing, but what you do is you put an absolute value around the velocity, and that treats all of the motion as though it's positive. If you're thinking of a graph, because I'm a very visual person, any of the areas below sea level, it's just going to treat those like they are above sea level and add them all up. So instead of the positives and negatives canceling out, it'll just count them all like they're positive. Is that making sense? It's very intuitive, all right? And then the last one, I wrote a little bit too big. I'm going to kind of write smaller here. Your position is equal to your initial condition, which, what is that? What's your initial condition? Yeah, whatever they give, it's where you started. So it's your initial condition plus displacement. It's like with the monkey and the gopher. We took where they started and we added on their accumulation. I get that sometimes you subtract. Remember the M&Ms, we were eating them, so we subtracted the M&Ms eaten. You have to think in context of the problem, but you write it, initial conditions, it's where you started, plus your displacement. Oh, you did that in the delta math. Remember you took the number you started at plus an integral? Yeah. It just didn't really make much sense because there wasn't a story attached. It was just random numbers, but that's what you're doing. So we're just going to use words like velocity now, but we're not doing anything different mathematically. So let's look at this one. The graph to the right shows what? What did they give us? Velocity, which is good. That's your rate. That's the derivative. From 0 to 11, we have a semicircle and 2 line segments. Let's answer the questions. Find the total distance traveled. That means integral from when to when. 0 to 11. And total distance means you need the absolute value. So that's the setup. On your AP exam, don't skip the setup. It's usually worth a point. It's usually a point for the setup and then a point for the answer. So don't skip that, because if your answer is wrong, you will lose both points. So now we're going to have to come over here and find all our areas. Semicircle is 1/2 pi r squared. What's the radius of that semicircle? It's 2. 2 squared is 4. Half of that is 2. So 2 pi. I agree. Then we've got this really big triangle, 1/2 base times height. The base is, let's see, 1, 2, 3, 4, 5, 6. And the height is also 6. So that would be what? 18, but it'll be negative. Good job. All right, and then the last one, 1/2 base times height will be 1.5. Good. Or 3/2 if you're a fractional purist. So what we're going to do is we're going to add all those together, but just treat them all like they are positive. So it's going to be 2 pi plus what? 19.5. So you add them all up, but just treat them all like they are positive. Now, there weren't any units given in this, but the units would be like feet, meters, yards. It's not a per anything. It's just a distance that you went, just that far. All right. So find the value of this one. It's practically the exact same we just did. and explain what it means in the context. There's not any context, so it's going to sound kind of silly because we don't have any units, but we'll do the best we can. So you want to use a word like displacement or total distance. So what is this? That's displacement because it doesn't have absolute value. And what you're going to do is just add these all up, but you're just going to treat them as they are. So it would be 2 pi, and then what would this be together? Minus 18 plus 1.5 would be negative 16.5. So that number, whatever that comes out to, is displacement. And I'm going to show you how to write it, even though this one doesn't really have a story. Is displacement in units, which would be like feet, yards, meters, displacement in whatever that is, from 0 to 11, whatever those units are. And that's going to be a time, like hours or seconds or minutes or something like that. Do you get what I'm saying? Like that's how you would phrase it. This one just didn't have any units. So there really wasn't any context. All right, if the initial position is given by x of 0 equals 2, that means your initial place that you're starting is 2. And your accumulation begins when? Now this, oh, I bumped the projector. Hold on. I made this one 0, but like you guys did on your delta math, you remember that could be any number? Just, use what they gave you. All right. So it says find the position at time 11. So it's 2 plus your accumulation 0 to 11. And then your rate is what goes inside of there. The derivative is what goes in there, which is velocity. So it's going to be 2 plus what we just found here. Here, I'll write it out so you can see it. It's 2 plus this 2 pi minus 16.5. And so that would be 2 pi minus 14.5, just to like finish it all up. You guys all look super tired today. That wasn't too bad though, right? Okay. Today is not a real difficult day. All right. What were we given in this one? Rate. That means velocity. In kilometers per hour. Do you see how there's a per? It's something per something else. Most of the time they give you the velocity. They're going to give you the derivative because that's the thing that you need. Okay. Our interval is from 0 to 4. Time is measured in hours. This is your hot air balloon. We did this same exact problem earlier in the year. We're revisiting it from the other side of the aisle from this integration standpoint. So your hot air balloon is initially where? That's so that you can get on. Okay. Well, I say that because as soon as I type this in, everyone loses their mind. Okay. So watch me type this in. Now I'm going to type it with X's because it won't give you a graph if you type it with T's. All right. So x to the third minus 4x squared plus 6. Now I already did this, but you need to be aware of your window. I'm going to come over here and hit the little gear. Do you see that? And do you see my x-axis, how I made it 0 to 4? The standard is going to be negative 10 to 10. Or if you've moved it around, it might be something else wacky. But if you want to make it whatever it's, do you see on the paper where it says 0 to 4? So you guys look really sleepy. I'm just trying to make sure you understand what I'm saying. 0 to 4. Okay. So that we can see everything that we need. So what always happens is people go, oh, the balloon started up here in the air. No, where's the balloon? You're not looking at position. The balloon's on the ground. This is velocity. The fact that this is all positive accumulation means the balloon first went. That makes sense, right? Because if it starts on the ground, it can't go down. A hot air balloon can't burrow into the ground like the gopher problem we were doing, right? So the balloon starts on the ground. It goes up, then it goes down, and then it goes up again. Should you exit the ride at the end of these 4 hours? No. No, because where's the balloon? Up there in the air would not be advisable. All right, so now that we've, verified what's going on in this problem, let's read what they want from us. So now we understand what's going on. When, so this should be a time, is the balloon closest to the ground? That means a minimum, and you just took a quiz. That's a change from what to what? Good, negative to positive. And then what is the altitude at that time? All right, so I want you to look at this graph. Whereabouts do we have a change from negative to positive? Like there-ish, right? Okay. So at that time, so write it on your paper. I'm not going to go back and forth because I'm going to finish the problem first. Time equals 3.514 hours. Actually, I guess I will have to go back to my paper to write this down. So time 3.514 hours. Now there's a follow-up question, which is what? What is the altitude at that time? Where did the balloon start? See, I'm going to write it anyway. It's your initial condition plus your displacement. If you don't want to write the 0 plus, that's fine. I'm just bringing it up because that's where the balloon started. And then what would your boundaries be? 0 to that v of t dt. So that's what I'm going to go type in. Now, you know how I said I wasn't sure how to copy paste this? I looked up and I asked a few other people. This is the best thing I've come up with, but it does make it accurate enough. Do you see this little like export button? That just puts it over here and then you can copy and paste it. So I'm going to type int for integral 0 to, watch me do this. I'm going to copy it and then paste it right there. Do you see how I did that? All right. And then it is t to the third. What was next? Minus 4t squared plus 6 dt. So the balloon is 1.348. Now it's 1.348 what? Please go back and reread the problem. What is it? Kilometers. Good. I wish I had put these in a different order. I'm actually going to do part D next because it partners nicely with this one. This was closest to the ground. What is D asking for? Yeah, maximum. When is it the highest up? Maximum is a change what to what? Positive to negative. So do you see that on here? Like right about there-ish? So on your paper, you're going to write time 1.571 hours. And then we're going to do literally the exact same thing. Yes, still starting at 0. Here, I'll show you. Should look like that. I basically rewrote what I did in part A, but I just changed that number. Yeah, I mean, we're all doing, these are all parts of the same problem, so it's not going to change. And again, in this one, it's 0, but sometimes it's not. So just be careful where your accumulation starts. So what I'm going to do is come over here. I'm going to delete this. I'm going to export this point and copy and paste it. Oops, not the whole thing. Right there. All right, how far up is the balloon? Yep, 5.779 kilometers. Why is that number bigger than the other one that we got? The maximum. Okay. That's pretty far. I don't know if a balloon can go up that. Can a balloon? To like, yeah. Isn't it 2.5 kilometers roughly makes a mile? Is that right? The other way around? Did I say it the other way around? Miles are bigger than kilometers. Yeah. Whatever. Anyway, you might need an oxygen mask. All right. Find the value of this and explain what it means in the context of the problem. Before I even type it in, is it displacement or is it total distance? Why is it displacement? It's not an absolute value. All right, everybody watch. I am just going to go back to what I had. I don't need this anymore. And I'm going to change this number to what? 4. Boom. There we go. I know usually we truncate, but that is kind of evil. So I'm going to actually round up 2.667. $2.667 is displacement in kilometers, and then you have to say one other thing or they won't give it to you. What's the other thing we got to mention? Good. You always have to mention the time. So from 0 to 4, and what was our time units? Hours. That's like with all the other things we were doing. Particle speed is increasing at time 3. Wasn't that what it was on your last test? Like at time 3 or whatever. That's like saying the at time 3. You're saying from 0 to 4 hours. This is going to be practically the exact same thing, except instead of displacement, this one is, why is it total distance? It's absolute value. Okay, so watch. So I don't have to type the whole thing all over again. I'm going to highlight this, come down here into this menu, and do you see your absolute value there? Boom. 11.528. And that answer is larger, which makes sense, right? Okay. Is total distance in kilometers from 0 to 4 hours. Okay, we got one more. I think I made this one a table problem tonight. Yeah. And I was kind of silly about the units. Can you go ahead and read it? I did it just to be funny because it's almost always feet per second. So I did this one just to be silly, just to keep you on your toes. This one is what? Nanometers per decade is what I made it just to, just for us to do something different. I was sick of feet and seconds. All right. So this is velocity. This is acceleration. Actually, this is not velocity acceleration. These are some random velocities and accelerations. We don't have any actual functions to use. Anyway, here we go. Use a left Riemann sum. Ooh, how many intervals do we have? Sub-intervals do we have? We have 3 sub-intervals. Every time you see this, you want to be like, yes, I'm going to get all these points. Is that what your brain does? Like, yes, I'm going to get all these points. All right. Or no. I feel like these are ones we got to get. All right. What's the length of your first sub-interval? 2? Now, hold on. Are we using velocity or acceleration? Yeah, velocity. And is it a left or a right? Left. Okay, so from 0 to 2, the number on the left, 5. Good. Plus, what's the length of your second sub-interval? 4, and the number on the left is 3. And then the last one, from 6 to 10 is 4, and times -1. Show the computation. Please don't do anything to that. All right? Leave it like that. And explain the meaning. Displacement or total distance is good. Is displacement in... Nope. We're going to get to that. Displacement in nanometers from 0 to 10 decades. Lovely. Yeah, good. Correct. It does not have an absolute value. So that's displacement. Is that approximation an overestimate or an underestimate is what this is asking. Greater or less than the actual, you get that that's an approximation, right? We didn't find it exactly because we don't have a function. What do you notice is happening with your velocity numbers? 5, 3, -1, -8. I usually just go like that. They are decreasing. They're going down. And we did a, which sum? Left or right? Left sum. So what do you think? Overestimate. So overestimate because velocity is decreasing. And this is a left sum. Right. So if the velocity values were going up, you would say underestimate because velocity is increasing and this is a left sum. You okay? I feel like I'm not trying to torture you guys. I know we have to go to school 5 days in a row this week. What the heck? I know. This is crazy. Yeah, but I feel like what you have is harder than what we're going to do. So, all right. Approximate the value of this. Oh, using a what? What does this one say? Trapezoidal. With the 3 sub-intervals, we're still using velocities. But listen, this is a very commonly missed thing. You're going to do your trapezoidal sum, but you're going to treat all the numbers like they are positive. We just said that, but it's like, it's hard to remember to do it. All right, 1/2, just because it's part of the formula. What's the length of your first sub-interval? 2. And then you add them together, so 5 plus 3. Usually they say show your computations. So don't write 8, write 5 plus 3. I'm sorry, I'm not trying to be hateful. I want you to get all the points, all right? Plus, now I don't want to move my paper up and down. You have the chart in front of you. What's the next one? 4. Well, hold on. 1/2, good. 4. Good. 3 plus 1. Plus And then the last one is 1/2 for 1 plus 8. Good. Is that whatever it is, displacement or total distance? Good. Why total distance? Absolute value. You're like, why does she keep like nagging us about it? Because people get it wrong on the test, and it's a really simple thing. Displacement doesn't have an absolute value, total distance does, and it makes sense because total distance should be bigger. But people mix them up, so that's why I'm nagging you. Is the total distance what? In nanometers from 0 to 10 decades. I don't know the abbreviation for nanometers. Is it NM? Oh, is it a symbol?
Is it like
Yeah, I was about to say that, but I didn't want to be wrong and feel stupid. Is it like that?
Wait, that's
That looks like something.
Oh, okay.
Is it like?
Okay, last one. Determine the value of this. Notice it says determine the value. We're not approximating. We're going to find it exactly. This is not an approximation. You're like, how could we do that? We don't have any actual functions. All we have are these numbers. Well, they have to make it work out so that you use the numbers in the table. And it's super tricky because they wrote acceleration here. You are still not going to use these numbers at all. Go ahead. Are you going to say the answer? I feel like you are. So antiderivative, you're correct though. Antiderivative. So if you have acceleration and you go backwards, you're doing an antiderivative, that takes you back to velocity such that 0 to 10. What is that called?
Fundamental theorem of calculus.
Right. Fundamental theorem of calculus. Antiderivative, upper minus lower.
No.
So it's upper minus lower. Those values are on the table, so we can find them. They have to give you something that's going to work out. All right, what is V of 10? Just go ahead and find it on there. -8. And then V of 0, 5. So that comes out to -13. Now, we want to write what that means in the context of the problem. That came out negative. So that means the velocity did what? So that's negative. The velocity decreased 13 nanometers per decade. Per is important there, something per something else. Velocity decreased 13 nanometers per decade from 0 to 10 decades. So not only is this thing moving in nanometers per decade, it's also
-13.
yeah, like yeah, well, although actually speeding up and slowing down, you have to look at both, and both of these are negative, so actually it would be speeding up, I say that, but I didn't ask you that question here.